What's chemical engineering? You know, chemical engineering, one of the broadest fields of engineering, and it is the most interdisciplinary in nature because the breadth stems from the fact that this discipline is founded on mathematics and all the basic sciences like chemistry, physics, and biology, and making it an interesting interdisciplinary field of study. Okay, this profession in which the knowledge of mathematics, physics, chemistry, and biology gained by the study, experience, and practice is applied with judgment to develop some economical and safest ways of using the materials to the benefit of the mankind. And in this process, there is no compromise with the environment, safety, or finite sources. Okay, so in this way, this chemical engineering also called as liberal arts of engineering because the chemical engineering graduate does not just gets into a chemical industry, he is getting such a skill set so that he could be able to contribute and stand on its own into these business management, banking sectors, finance sectors, law, teaching, medicine, or as an entrepreneur. Okay, so that way this chemical engineering is a broad field. And what do a chemical engineering role in this world? Please listen, watch this video.
What in the world do chemical engineers do?
As a chemical engineer, we are making life-saving medicines accessible to everyone, and we are developing some new energy sources more safely and responsibly. And we eliminate the plastic waste from the oceans. When it comes to getting things done, chemical engineers use mathematics, physics, chemistry, and biological knowledge to make medicines accessible to everyone, water drinkable, air breathable, and deep thinking to make environment sustainable and the system affordable and safety is reliable. We make discoveries scalable, conceivable, and feasible. And we take things that have never been done before and we get them done for a world of good. That's the role of a chemical engineer. From the development of smaller, faster computer chips to innovations in recycling, treating diseases, cleaning water, and generating energy, the processes and products that a chemical engineers have helped create has touched every aspect of our life. That's why we used to say, since you get up in the morning, you start using toothbrush and toothbrush, which is made by chemical engineer, and at the end of the day you go to bed, foam mattresses made by chemical engineers, and you switch on the mosquito repellents which are again developed by chemical engineers. So that way starting from our day begins and ends with the products that are developed by chemical engineers. So this chemical engineering is both an art and a science because it's not that science will give us all the answers. Many times chemical engineer has to use his experience and wise and taking some judicial decisions. Okay, so we have to make some judgments and take a decision so that it works. At the end, it should benefit the society and the mankind. Okay, so that's why the professional stature of an engineer depends upon the skill in utilizing all the resources that are information to reach a practical solution to processing the problems. Okay, so as a chemical engineer, we will be developing, designing, and optimizing both the complete process, how the process is done, as well as the equipment used. And we have to choose the proper raw material for the given operations, and we have to operate the plants more efficiently, safely, eco-friendly, and economically also. And we have to ensure that the products that are produced in a chemical industry meets the requirements of the customer. Right? Finally, customer satisfaction is important. The customer will give the specifications. My chemical should have this much properties. My product should have this much texture, or even with respect to aesthetic look also, right? So that way, finally, we have to satisfy the customer in doing whatever we are doing. So to summarize, a chemical engineer, we are advancing the biomedicine research. So even any vaccine is prepared to make them in a large scale, we are helping them. We are developing some electronics, all the products that are present in the in your laptops and all, battery production, say supercapacitor production, fuel cell production, chemical engineers are working. And chemical engineers are enhancing the fruit production and fruit safety. And chemical engineers are generating energy, renewable energies also we are working on, and we are improving the materials with enhanced properties. And we are trying to save this environment by doing some remediation processes. If you look at a chemical industry, a typical chemical industry will have certain unit operations and unit processes. Chemical plant will have, for example, see why I am showing you this is, as a chemical engineer, it is our responsibility to develop a plant layout or process flow diagram. Even for we have to perform the material balance and energy balance in the system, and it is a prerequisite to design any chemical engineering equipment also, right? Because once we want to say we need a pump, we first for our apartment or houses, how much water we need per day. Accordingly, what is the capacity of the overhead tank, what is the capacity of the sump tank, then we are going to recommend a pump. Okay, you need such pump. Also based on the location, if it is a borewell pump, how depth the water is available, accordingly we are going to choose the horsepower of the pump and the head developed by the pump. Okay, so that way we, as a chemical engineer, it is our responsibility to not only design the plant, also it's our responsibility to design the equipment also, right? So to design an equipment, we should know how much material is handled by the equipment, right? So that way it is a prerequisite. So a thorough understanding of these various system of unit conversions also coming into picture in this case. Okay, a typical chemical plant will have some storage tank. That is what we will be buying the raw materials, right? Different raw materials needs to be stored at different temperatures or pressures, or some may be stored in liquid phase, or some may be stored in gas phase. So all the safety has to be done, and that should be stored properly. And if it is solid, if it is a solid raw material, we may have to do some size reductions. For example, in a coal power plant, coal blocks will be imported, so that will be stored, right? So we may have to do some size reduction of the raw material. Okay, it's not that all the operations are present in the industry, but in general, whatever raw material is there, there can be a size reduction